Good afternoon. My name is Greg Fitzpatrick, and I work in business development in the area of IoT and integration for Cochrane Supply Engineering. And I'd like to welcome you to our first webinar of our Smart Building Design series entitled How to Design an OT Network. First of all, I'd like to thank you guys for coming out and joining us today. We really do appreciate your time considering, all that's going on as it relates to the coronavirus, all this uncertainty in our economy, and of course, the questions we have regarding how this is going to affect our industry as a whole, in addition to our individual companies and our families. So hopefully this webinar will give us all a sense of connectivity to both our industry and, a sense of connectivity and normality when it comes to our day-to-day lives. A couple housekeeping items here. First, we're going to record and email a copy of this webinar to everyone on the line today. So if there's some things that we go over and you don't quite get, please feel free to review it at a later date and get back to us. And secondly, due to the amount of time that we have here, we're not going to take any questions during this webinar, but what I ask is that you email me at gfitzpatrick CochraneSupply.com. We're going to show you your email address at the end of this webinar. First, I'd like to tell you a little bit about myself. Like I said, my name is Greg Fitzpatrick. I've been in business for over 25 years. Worked for a consulting engineering firm years ago. Also worked as an equipment manufacturer's rep for both Train and Carrier. So I sold equipment, controls, turnkey projects, performance contracts, and all that good stuff. I worked also as an owner's representative for a large bond program. I worked as a commissioning agent and was director of facilities for a very large school district with over 100 buildings. So I've seen a lot, in my career, and I understand our ecosystem and how things work and where our business is going, and of course, more importantly, where our industry has been. So let's talk about my family. Told you who I was or what I did, but this is who I am. I got three wonderful children from left to right. One on the left is Desmond. He's a senior at the University of Louisville, wide receiver. The one in the middle who looks ecstatic that I jumped in the middle of her selfie is the oldest. That's my daughter, Brianna. And the young man to the right is Christian. That's my younger son who's following in his brother's footsteps as a wide receiver at the University of Louisville. So that's who I am. Let's talk about Cochrane Supply. Most of you on the line do know us and you are familiar with us in this industry. We've been in the industry for about 50 years or so, started off as a distributor of pieces and parts. And over the years, we kind of developed into what I like to call an IoT and integration hardware and software solutions provider to support, the building technology industry. We've got 6 locations throughout the Midwest. We provide technical support, software development. We've got an IT group, and we have a large training center. So that's who Cochrane Supply is. So let's jump into this webinar and talk a little bit about our industry and where we've been. Like I said, this is the first of a 4-part series of our Smart Building Design series, right? So we've got 4 parts. The first is how to design an OT network. That's what we're going to talk about today. Part 2 is how to specify Niagara, with parts 3 and 4 being introduction to cybersecurity, and then how to specify integration, which is going to be very important for end users and consulting engineers alike. One thing that I noticed is that we have a group of consulting engineers, end users, and systems integrators on the line. So we've got a pretty mixed bag of some of our industry professionals. So what we're going to do is talk to you about how to design an OT network from the 2 different perspectives, right? From a design perspective as a consulting engineer and from a design perspective as a systems integrator. So a couple of things we're going to cover today. We're going to talk about IP devices and why our industry is moving to IP devices. We're going to talk a little bit about what operational technology networks or OT networks actually are and why they're so important. I'm going to touch on cybersecurity very briefly because we do have a separate presentation for that. And we're going to get into selecting an OT network solutions, going to the fundamentals of designing one of those systems. And we've got a very small portion of an example project that we kind of want to run through with you guys. So most of you who are familiar with Cochrane Supply Engineering have probably seen this slide before. Both Scott Cochran and myself, we love to use a slide because it kind of talks about our industry as a whole and where we have been as an industry, right? I always talk about our industry as an ecosystem. So what I like to do is kind of refer to, our ecosystem as to where we've been and where we are going. So traditionally, we always have the separate building stakeholders that will come in and install their separate networks for their software solutions, right? So you end up having the HVAC contractor in your building installing his network, life safety, security, electrical. They would all install their own separate networks, their own separate control devices, and their own software solutions that will be loaded on the owner's desktop computer in some facilities office. And you have to go to each one of those different programs to actually pull up their systems. Well, back in 1999, I think it was, this sorcery that the industry liked to call it early on, called Niagara, developed by Tritium, came along as this aggregated software platform or this integration software, that allowed contractors to come in and take each one of those systems, put them on a common graphical user interface, and be able to view and control each one of those systems from one front end. Well, what that did is kind of introduced a new type of contractor to the industry that we like to call the systems integrator, right? Because after we started integrating these systems, we started connecting these systems to the internet, which actually kind of introduced this entirely different set of skills that our typical controls contractor had to have, right? So the traditional controls contractor, their capabilities usually included mechanical system design or electrical capabilities. And as soon as you started connecting these systems to the internet, now all of a sudden a whole can of worms opened up and these guys had to have IT capabilities, right? They had to know a little bit about cybersecurity, know how to stand up firewalls, had to learn how to actually implement authentication processes, right? And had to actually learn other scripted languages like Java and things like that that are actually part of the IP world. Okay, so now we have this shift in the industry, and then we started introducing these contractors, right? So they're called systems integrators now, opposed to controls contractors. And I'm not going to spend too much time on this slide. Most of you on the line have seen something similar to this. So we're just going to kind of breeze through this. But, knowing that now we've got a new systems integrator that's introduced to our ecosystem, it gave the owners and building designers far more capabilities than they had before when it came to, collecting data, aggregating data, and making this data useful for the owner. The systems integrator ended up being a trusted advisor for the owners when it came to HVAC, lighting controls, life safety, data centers, all that good stuff. And so now they're solutions providers opposed to just contractors, right? They're technology experts. So now we've got this contractor on board that knows how to manage all of this data that we're collecting from all of these devices. So now what happens? We hit the smart building craze. So what is a smart building? There's a lot of definitions out there as to what a smart building is, but a smart building is pretty simple. A smart building is actually a building or any structure that takes all these different sensory networks and the devices in these sensory networks that collect data, and they actually take this data, allows you to manage this data so that you can use this data for anything from analytics to any other applications that you guys want to use to improve your core business or to improve energy consumption, right? So what does that mean? Well, now we've got smart buildings and we've got owners saying that, look, we want to charge more per square foot for our building. So how do we, create a space that's designed to enhance the occupant's experience? Well, first of all, a lot of owners are interested in what? Analytics, right? Every owner wants to save money. So there's applications out there for analytics. You've got all these applications that are developed for asset tracking, right? So now we've got lighting systems with Bluetooth beacons in them that can actually attach to a third-party application that allows you to track assets, right? Or do space utilization and know when conference rooms are open. Or you can actually do geofencing. So what I'm saying is that all of this data collection and data manipulation, data aggregation is all part of this new connected world that we live in. Okay, so we're here to talk about OT networks or IP networks. So why are we talking about this? Well, first of all, our industry is starting to move to IP devices, right? A lot of you on the line have heard this before. You've heard it in different conferences. You may have seen presentations when it comes to IP networks, and you say to yourself, so why is the industry moving to IP networks? Well, all the major manufacturers have started developing their own series, so to speak, of IP devices. And it's simple. Ethernet moves more data, right? We talked about, how data driven, our society is now, and how data driven all these applications are now. So now you're talking about providing a controller that's a little more powerful, where you can run analytics at the edge or at the controller level, right? And it's easier to share data when you're talking about different operational technology sitting on your network when you have IP devices. So that's why we're moving to IP devices. So this presentation is called How to Design an OT Network. What is OT? Well, OT is operational technology. Simply put, anything in your building that is bolted to the building. So in other words, your lighting systems, that would be operational technology, right? Your HVAC systems, access control, fire alarm systems, elevators and escalators. All those things are considered operational technology. So we're talking about machine to machine learning, right? We're talking about machine to machine communication, opposed to IT, which is informational technology or information technology. So when you look at the two side by side here, there's a big difference between IT or information technology and OT. They behave entirely different on a network. So when you're looking at operational technology, like I said before, it's machine to machine communication. Operational technology is typically maintained by a facilities engineer, right? Not by an IT professional. Operational technology is always associated with critical building functions, whether it's HVAC, lighting, power, energy, right? And all those devices that are on those networks are typically predictable in nature. When you're looking at IT, which is information technology, like your email, like CRM programs, like accounting software, all that stuff is actually people to people or user numbers, credit card information, and things like that. And all that information behaves entirely different. It has dynamic traffic profiles on the network, and the bandwidth is entirely different. So there's a difference between IT and OT. So the main question is, why should we have our operational technology consistently sitting on the owner's IT network that is set up and made and managed by IT experts, right? Now, there's some owners, large end users that I like to call enterprise customers that have what we call an IT OT convergence plan, right? But when possible, and especially if you're using IP devices, when possible, you should always stand up, install, manage, and service your own separate IP network. Okay, so why is an IT network or OT network, important? Well, first of all, cybersecurity risk. We've all heard about that, what was it, Target incident, right? Where someone left a laptop, I think it was a controls contractor left a laptop, someone found it, tunneled in, and got to all their corporate sensitive information. Well, what that does is it exposes everyone from the consulting engineer all the way to the contractor when it comes to liability, right? So now you're talking about systems that are being stood up and connected to the owner's IT network. And after it's connected to the owner's IT network, we have no control over what happens, right? Because we, as a OT society, like what I like to call us, we don't have any control over that IT network. So what we need now is capable contractors or systems integrators who are capable of standing up their own IP networks, right? And when I say standing up, I mean install, program, and manage those networks. And we need capable consulting engineers who know how to design these networks and put them in a set of construction documents. So that's what I hope we get to today. So one of the most important things, just like any solution, is trying to figure out how do we actually select the right solution, right? So there's going to be a ton of, or at least a handful of products out there that you can choose from, that you can look at. And what you want to do is take some things into consideration when you're doing it. And here's a list of what I think are the important aspects or elements to selecting an OT network. First is ease of design, installation, and management, right? So in other words, give me a product or a solution that's easy for the consulting engineering community to understand and to design and lay out and put in construction documents. Easy for the contractors to actually install, program, and manage. Because a lot of these systems or OT networks are now about to be a part of your offering as a systems integrator, right? So we want this ease of design, installation, and management. Secondly, you want it to be scalable, right? You want it to be scalable. Any solution that you install at this point needs to be scalable so that you future-proof your owner's building. So in other words, this product needs to be able that if you install it in a campus environment and there's a capital improvement project that includes 3 new buildings at some point, we want to be able to scale this solution and build this network out. Next, flexibility when it comes to system architecture, right? So whether you're talking about designing a shopping center, higher learning, K through 12, or a high-rise building, right? We want that topology to be flexible in nature so that we can actually design any type of network that we want. You also want your solution to have network management capabilities, right? So when I say network management capabilities, we're talking about the front-end network management switch that's going to manage your entire network. We need that network management switch to have a graphical user interface so that we can see all of our switches, so that we can see all the ports, so that we can see the bandwidth, right? So, and it takes us to the next few things I have listed here. You know, you want a solution that's going to have a front-end graphical user interface, manage switches out there in your network, so that with this graphical user interface, you can see every port, you can open and close them, right? You can secure your ports, whether something's plugged in or not. You can set up VLANs because you have to anticipate that if not during the installation, maybe down the line, if you only have HVAC and say lighting on this network, you want the ability to add fire alarm, elevators and escalators, card access, whatever you want to add, because remember we talked about scalability. So you want the capability to set up VLANs at some point. And you also want to be able to monitor the bandwidth on your network. Okay, so let's start looking at pieces and parts, what I like to call them. And this is pretty essential when you're starting off from scratch and you're conceptually putting something together, whether you're putting together a chilled water system, an air system. You know, from my consulting engineering days, I always like to go back to, okay, so what's the foundation for my design? So what I like to show you here is a list of hardware and software that you're going to need to stand up your network. From left to right, we're talking about a server rack or a control cabinet, right? So that you can install your server. So for this example we're going over today, we're going to talk about an on-premise server. We're standing up an IP network that is totally separate from the owner's network. Go back a slide here. From the owner's network. So what we're going to have here is a server that's going to be on premise. Then your integration software, right? Your front end software, what the consulting engineering community likes to call it. So your front end software is going to be Niagara 4. Now, we're not going to get a lot into manufacturers or products, but I do like to talk about Niagara, and you do see that we're going to have a how to specify Niagara presentation, as part of our design series. But, I want to make sure that I pointed out here that we're going to use Niagara as basis of design for this solution. You're going to want to make sure that the solution that you chose, like I said before, has a network management switch, and you're going to need media, right? So how are we going to connect our switches out in our network? Is it going to be fiber, or is it going to be Ethernet, right? Cat 6. Then you're going to need what I like to call edge switches. These are the switches that are going to be part of the network. Then you're going to need a physical firewall, right? Firewall and the DNS. This is, all part of our cybersecurity, because every good design needs 3 points of protection, and we'll talk about that a little later, but this is one of those points of protection when it comes to cybersecurity. You're going to need wireless access points, a layer 3 router, power distribution unit, and a UPS. Okay, so let's talk about this smart building platform, is what I like to call it. So when we're standing up an entire separate OT network, we broke it down into 2 parts, with the front end or the integration platform being the brain and the operational technology network being the spine. So hopefully this makes it a little more easy to understand when you look at it pictorially. So you've got your front end on one side, then you've got your network on the other side. So when you look at the brain of the system, which is your front end, it's going to include all these pieces of parts, right? Hardware and software. Your main server, integration software, which is our Tritium Niagara, firewall and DNS, our distribution unit, a UPS, and a server rack. All right, so let's go back a couple slides here. So you see all those pieces and parts there are included in the brain. So let's kind of walk through this stuff. So imagine you're installing your own separate OT network as a contractor, or you as a design engineer, you're designing a system. Well, visually, I like to show pictures because it kind of gives you a clear understanding of what you need to get on the drawings to pretty much get your design intent across to the contractors if you're a consulting engineer. And the contractors, you guys are familiar with all this stuff, and you've installed it before. You know what most of this looks like, but we want to put it in, one picture or one package so that you guys see all the pieces and parts you're going to need to stand up your own IP network, self-contained IP network. So you're going to have a server. It's probably a good idea to have a monitor and keyboard so that you can access, your system from right there. You don't want a combination firewall and DNS. There's products out there that are a combination of the two. Your power distribution and your UPS. Now imagine all this stuff being in a server rack in the facility manager's office. And then, of course, to the top right is your integration software that's going to be installed on that main server. So let's talk about the software briefly. The software is Tritium's Niagara 4. This is where you're going to integrate all of your OT, right? So once you integrate all these systems, you develop your graphics, right? So that everything looks the same, whether we're talking HVAC, lighting, fire alarm systems, elevators and escalators, energy, whatever it is, your systems integrator or master systems integrator is going to use this integration software to integrate all this operational technology into one platform. So this is where all the equipment scheduling can be done. All your trends will be set up here, any alarms, all the graphics, like I mentioned before, any dashboards that the owner may want. So a C-level guy may want to walk in and just see certain things, right? If you're a school district, facilities director for a school district, you may just want to see if your heating system is working or if your cooling system is working in the summertime and see if you have power in the building. So you can develop all these dashboards there, and all data tagging will be done from this front-end integration software. So the server, right? This is where we all know what a server is, and this is where all of your software is going to be stored, right? So any software that's actually set up to manage any of those applications out there on your network, that software can be hosted here on the server. All your data backup, right? This is where Niagara 4 is going to be actually deployed, right? So this server is separate from your owner's IT server, totally separate. So you're standing up your own server. You're going to manage the server once you leave the job, right? And this server will be the brain, essentially, of your entire OT network. And then the firewall. We all know what a firewall is, right? It provides that defense against cybersecurity, right? And then we like to specify a combination of firewall and DNS so that we can, set up all of our IP addresses and all that good stuff. And a lot of these products have an optional VPN and cell modem so that everything is there in case you want to connect to the internet. Power distribution unit, we won't go too far into this. We know what this is. This is a place for us to plug in all of our hardware devices. But we always recommend that you get something that is IP capable, right? So that you can pretty much access this power distribution unit from anywhere on the network. So if you've got a network with multiple buildings, you should be able to jump on the wireless access point. You should be able to access this power distribution unit and possibly reset the network manager if you want to. So you can reset some of these power outlets individually. So this is something that if you call in and you talk to us, we can help you specify the right, what we like to call the network grade power distribution control unit. And then we all know what a UPS is to make sure we provide protection for all of our electrical components in that cabinet. So at the end of the day, this is the hardware and software, right? This is the hardware and software included in our front end, right? So let's keep going here. So now we're talking about our layer 3 router, and you'll see where this layer 3 router falls when it comes to overall topology, but you need a layer 3 router to actually manage all your IP addresses, has inter-VLAN management capabilities, okay? So that you can route certain operational technology to certain applications, right? To make sure that you keep all of your OT separate. So in other words, in addition to setting up your VLANs with your network manager, then we make sure that all that information gets routed to the right place on our server. And then, we won't get into all this IP stuff, but has the ability to make sure that, you can change the data packets and frames on the network without changing the actual message. Because remember, data is only broadcasting messages, right? So we want to make sure that when these packets of data actually start moving on the network, that we can route that data without changing the message. And then the wireless access point. And we all know what that is. That's just giving us the ability to access the network wirelessly. So we've talked about the brain, the hardware and software that's involved in setting up our brain or our front end. So now let's talk about the spine. So the spine is our actual OT network, right? That OT network solution that I talked about. So when you look at the OT network, there's 3 main components. You've got your network manager, or what I like to call your network front end, right? This is where all the hardware and all the software resides that actually manages the entire IP network, right? Which is the spine. Then you have your edge switches, and we'll show you where that falls in the topology when we get a chance. And then you need some type of media to connect those edge switches and get everything back to your front end. So now we're talking about either fiber. Most solutions have either fiber or Cat6. That's how we pass data when we're talking about IP devices or IP networks. So when you're looking at hardware for your spine, like I said, you're talking about your edge switches, your network manager, and your network media, the three. If you look there at the bottom, to the right or to the left is an example of a network manager, right? A front end network manager. And then if you look to the far right, you've got an Ethernet connection here, or Cat6, and you have your fiber media. So now you've got your OT network solution. So let's look at what's going to be out in the network when we set up this topology, right? So now we're talking about managed edge switches. Okay, we're talking about managed edge switches that are specifically built for OT, and these are priced for the facilities world. So in other words, we're not purchasing large Cisco switches or anything like that are $20,000, $30,000, for operational technology. Remember, we're talking OT and not IT. So there are solutions out there that are built for the facilities industry and priced that way. So most of these solutions have the capability to go from 4 ports all the way to 24 ports, that gives you the flexibility to design a system any way you want to. So remember, we talked about, flexibility and scalability. That's what you're going to want to look for when you're talking about your solution. Network media, like I said, we're getting away from that MSTP, which requires, the old 485 networks. We're getting away from that. We're talking IP devices now. We need that capability to move more data. We need that capability to run applications at the edge. So now we're talking about a different type of media to network our entire solution together. So now we're talking Cat6, single mode fiber, multi-mode fiber. Those are your 3 options that you have when you're talking about networking and OT solution, right? So if you look to the top left, single mode fiber, that's typically what you're looking at, right? And there's a different school of thought for which actual media you want to use. But when you look at some of these solutions, some of them use a combination of single mode fiber and Cat6. It depends on the application. So, if you guys have some design questions, like I said, feel free to shoot those to me. We've laid out a lot of systems for both engineers and systems integrators, and we can help you, select a solution and help you select the media that goes along with it. So now let's talk about that front end for the network, right? Our OT network. Let's talk about that front end. That's the front end management system, your network manager. So when you're looking at a solution and you're trying to decide which one you want to go with, you're going to want a solution that has a graphical user interface that's easy to use and makes it easy to manage every one of the switches out there on your network, right? So what are some of the things you want to look for? Well, you're going to want to look for port management and port security, right? That means the ability to go to each one of these switches, right? We want the ability to go to each one of these switches and see exactly what's going on with every port on that switch, right? Is something connected to that port, right? What is the MAC address that's connected to that port? If there's an open port, do we want to close that port and secure it, right? So we want to be able to see all these ports when we're looking at the front end graphical user interface for the network manager. You want the ability, like I said before, to set up VLANs. So we want to be able to truncate all of our HVAC together, or maybe our HVAC plant and the associated pumps. That's one VLAN. Then our air handling units and all the communication devices that go along with our air system. That's another VLAN. And then that's a sub VLAN. And then we VLAN all the HVAC together, right? You want to be able, if these switches have PoE capabilities, you want to be able to manage that PoE. See how much PoE is actually available for each switch. And then bandwidth monitoring. Remember, we're dealing with bandwidth when we're talking about either Cat6 or a fiber network. So we're talking about bandwidth availability when we're connecting devices. So now you want to be able to see, okay, I'm setting up my network. I've got half of my system connected. How much bandwidth have I used? Have I used 3/4 of the bandwidth? I may have an issue, right? So you want to be able to monitor the bandwidth when you're looking at your system. Okay, so let's do a real brief review here and talk about what we've gone over so far. So we're looking at this concept, and we've got the brain and the spine. The brain being the front end, and the spine being the OT network, right? So now we've got our brain, our integration software, our server, right, and all the pieces and parts that go in that rack. And then we've got our OT network, which has its own front end or network manager. Then we've got fiber, we've got Ethernet connecting all of these managed switches out there in this IP network. So how do I start a design? How do I start a design? So when I think about my old consulting engineering days, I always think about the design development. There's always a design development and a discovery stage, right? So if you're new to this, I would suggest that you set up a process similar to this so that you can understand exactly how to manage the process so that you don't have to recreate the wheel 2 and 3 times. So a couple questions you're going to want to ask during the discovery phase is, where will my server rack or my cabinet be located? For all intents and purposes, we're going to talk about a server rack here. So where am I going to mount that server rack? You want to find out if you're an engineer. When we're laying out our systems, we're always going to the architect and asking for a bigger mechanical room, or we're trying to ask the architect, where am I going to be able, where's the data center, right? Or the MDF cap or the MDF room. So this is going to be associated with facilities. So 9 times out of 10, it may be mounted in the facility manager's office. So that's one of the things you're going to make sure you work out in the very beginning. What technology is going to be integrated into the OT network? Are we just doing an integration project that just includes HVAC and lighting? All right. So if we've got HVAC and lighting, then you're going to build your topology a certain way. Like if you look at that last question, are there any plans for future expansion? You may want to, instead of selecting a 4-port switch because you only need 4 ports on your first floor, you may select an 8-port switch because they may want to add the generators later, or they may want to add the fire alarm panel later. So you're going to want to be very clear on what technology will be integrated into the OT network. And then you're going to want to know what type of protocols and networks or subnets will these technologies use, right? So you may have a job that's a flat architecture, which means you've got all IP devices. So you're daisy chaining a certain amount of VAV boxes because they're all IP, and you're running those straight back to a switch, right? Or you may have a combination of IP and BACnet MSTP. So you may have BACnet IP devices and BACnet MSTP devices in one job. If you're doing generators, there may be Modbus, but you're going to want to tie down what type of protocols and what type of networks will these technologies be using, because this is all going to be important information when you're trying to design your network. Then you're going to want to know whether or not you're connecting to the internet. Okay, so for this example, and for all intents and purposes today, there's no connection to the owner's IT network, and there's no connection to the internet. Okay, so now we've got our own standalone, self-contained IP network that can take care of all the operational technology in the building. Okay, so now we've gone through our design discovery phase. So let's talk about the small example project that we have. So we're going to walk through this example project briefly and just kind of try to design a OT network from the ground up. Okay, so for this example, we're going to use a healthcare facility. Okay, so we've got a healthcare facility. It's a multi-story building, 5 stories tall. Like I said before, we're going to have an on-premise server, an on-prem server that's rack mounted. Okay, so we showed you the slide earlier today that, we're going to mount all of our hardware in a rack, right? The integration software we're going to use is Tritium's Niagara 4. I mentioned it earlier that it's going to be standalone with no connection to the owner's IT, no internet connection. And today's example, we're going to actually integrate 4 different OT systems. We're going to integrate HVAC, emergency generators, fire alarm, and lighting controls. Okay, and we all know that fire alarm, typically if you integrate it to any building management system, it's only used for secondary annunciation, right? Because a fire alarm panels have their own set of jurisdictions when it comes to the fire marshal. So we don't, interfere with any of that stuff. We just want to see the fire alarm panel in our front end. So we've got 4 different technologies that are going to be integrated: HVAC, emergency generators, fire alarm, and lighting controls. So first, if I'm a consulting engineer, the most important thing is design intent. That is the most important thing, design intent. So when we're looking at it, remember we broke it down as the brain and the spine, okay? So let's look at the brain, the integration platform, or our front end. So when laying out a system, and this whether you're a systems integrator or a consulting engineer, you know, you're going to want to show some type of topology. So as a consulting engineer, you want to show enough to explain your design intent. So I always say that any good topology drawing, right? Any good topology drawing should be able to show your design intent to a systems integrator. So in other words, if I'm a systems integrator, I should be able to look at this drawing and know basically I should have 90% of my information right here and know what your intent is. Now, does that mean that everything is here? No. But I do know the intent as a systems integrator when I look at this drawing. I know how my front-end software or my integration platform software is being deployed, right? I know what that integration software is. So it's Niagara 4 being deployed on an on-site server, right? Is there a connection to the internet? Looking at this drawing, I would assume no, because nothing's shown. So this, to me, as a systems integrator, I look at this and I say, okay, it looks like they want redundant front ends for the network manager, right? In case one of the front ends fails, the other one lights up right now and your network is still accessible. It looks like we want wireless access. And it looks like we also want the ability to connect directly to the network via a hard line, right? So there may be a situation where you've got a facilities office and there's 4 guys sitting there. You want them to be able to plug into the Ethernet cable, take that Ethernet cable and plug right into their computers and pull up the network, right? So this is what you see. This is what you like to have when you're talking about setting up your front end. Now, as a systems integrator, I may provide a little more information because now they become as-built drawings, right? So we're talking about 2 different things here, but still the intent is shown here when you talk about the front end. So if you look at this legend to the bottom left, I know what type of media is actually connecting here, right? So that yellow is single mode fiber, so I know my solution is going to be a fiber-based solution. When you look at the wireless access point, and you look at those 4 hard connections to the on-site workstations, right? That blue line, those will all be Ethernet connections. And then there's a Cat6 for this particular solution. There's a Cat5 cable required to connect the redundant front end to the main front end. So this is your brain. So what does that brain look like when you show it in the cabinet? So if I'm putting together a systems integration drawing as a consulting engineer, I'm going to want to show a topology drawing, which includes this brain. And we're going to expand this drawing here shortly. which includes this brain, I'm going to want to put together a cabinet detail. Okay, so in other words, here's my server rack, and here's all the or all the hardware that's going to be installed in my server rack. So when you go back and look at this, right, you've got a 4-port switch, you've got a wireless access point, you've got a layer 3 router, you've got a couple front-end network managers, you've got a firewall, and an on-site server. And remember, the other components that are included would be your power distribution unit and your UPS. So let's go back here. Let's take an inventory. So from the top, there's your 4-port switch, right? There's your firewall, your layer 3 router, your UPS, your network controller, and this particular solution, the network controller and the user interface is two different components, but one solution. So you've got those in a redundant type situation there, right? So you've got 2 of each, and then you've got your server. Now that wireless access point, that may be installed somewhere else within the facility, but you've got that wireless access point that connects to that 4-port switch. So here's your front end, all the hardware and software. And remember that not everything is going to be loaded on this server. And that's what your cabinet would look like. So as a consulting engineer, I want to make sure on my systems integration drawing, right, my SI drawing, I want to show this diagram, the OT network MDF, right? So this is all the hardware that's going to be installed in that cabinet. So the next thing I want to do, and remember, we're trying to stay organized and methodical when laying out the system. So we started off from design discovery, right? We asked all our questions. We got all the information that we needed to know how we're going to design the system, right? So we know that we've got our on-site server. We know it's going to be mounted in the server rack. We know the location of it now. We know that we're going to deploy in Niagara, right? We know that we're going to have a wireless access point. So now we've got all of our pieces and parts installed in this cabinet. So now what we want to do is start laying out our system, starting at the controller level, all the way back to the front end, right? Because remember, we want to put together a clear and concise topology so that if I'm a consulting engineer putting together this topology, I show enough to show my design intent, right? If I am a systems integrator, then I'm going to want to go into more detail and lay out my sub networks, which may be my device networks, right? So if I've got 250 VAV boxes, right? Well, I want to show those sub networks that are networking those VAV boxes together, whether they're daisy chained or however we, connect those VAV boxes, whether it's 35 max or 50 max. We want to show those subnets as a systems integrator because that's the amount of information that's going to be required for A, my as-built, and B, to let me know exactly how much bandwidth is going to be needed and exactly how am I going to actually size each and every one of these switches, right? So you're going to want to put together a list of equipment. You're going to want to know the controller locations, right? So we want to know the area, what floor they're on, right? What they're actually controlling, right? So it goes back to our list of equipment. And then the communication protocols. And then the sub-network media. We talked about that, right? We may have a job that's not a totally, completely flat architecture with all IP devices. It may be a combination of, IP devices, right? There may be MSTP devices, there may be Modbus, there may be different network media in addition to protocol. So we want to make sure that we put together a schedule that shows this stuff, right? And then we're going to want to know the sub-network media and the quantities. So what does that look like? Okay, so let's take a look at what an actual integration schedule would look like, right? So this is pretty much a matrix. Now, as a consulting engineer, you don't want to put this on a drawing, right? But if I'm a systems integrator, I'm going to want to put together something like this just to make sure that I know all of the controllers that are actually on my sub networks, right? What the protocol is, and what the network media is, right? So if you look at the first floor, because we're only going to look at the first floor for this example, and you'll see all this technology when you see the overall drawing. We're only going to look at the first floor for now. So if you look at the first floor, there's the emergency generators, which is my bus, and we're going to look at the fire alarm panel, BACnet IP. So we've got Cat6. There's one H&V unit. That particular unit is has an IP controller, so there's going to be Cat6 there. The lighting controller, that's actually BACnet IP. So that's going to have Cat6. So when you see Cat6, then you know that that's an Ethernet connection that can connect directly to one of your network switches. Okay. So one of your edge switches, you can connect that controller directly to an edge switch. Okay. Now the VAV boxes, fan coil units, the crack unit heaters, convectors, duct heaters, air curtains, all of those are BACnet MSTP with RS-485. So you're going to do your sub networks, right, with your 485, but you also know that you're going to need a gateway device, right? A gateway device to connect to your network. So you're going to have to get all those copper connections, which are the RS-485 cable, to an Ethernet connection, right? And you do that through a gateway, right? Through a JACE. So this is the type of schedule you're going to want to put together when you show your overall topology. As a consulting engineer, you don't want to show the subnetworks. You want to show a VAV box controller typical for 52, right? So you as a consulting engineer, you have to know that, okay, well, a typical VAV box or IP type of network or subnetwork, you can typically only network or daisy chain, a minimum of this and a maximum of that. So you usually want to take a minimum. So if it's 52 and there's a minimum of 30, then you say to yourself, okay, well, I'm going to need 2 connections, right? I'm going to need to allow 2 IP connections for 52 VAV boxes, right? So the level of detail you show as a consulting engineer is going to be different from the level of detail that a systems integrator shows in his as-built drawings. So here's what that first floor looks like. Okay, now when you look at the first floor, and you're going to see the overall topology here shortly, but when you look at the first floor, you've got a 8-port switch, right? That's your blue thing there. You've got your 8-port switch. Then you've got your fire alarm panel. Now remember, all the blue lines are Cat6 or your Ethernet. The purple lines are actually 485. So you've got your fire alarm panel. So you've got 1 port dedicated for your fire alarm panel. You've got 1 port dedicated for your JACE at the bottom, right? Where your 2 emergency generators are connecting to. So you're going to run your emergency generators to that JACE, and then you're going to allow 1 port for that JACE. So we've now used up 2 ports on the 8-port switch that's on our first floor. Now we've got BACnet MSTP VAV boxes, right? So we're using 485, which is your purple line there, to network those devices. So for here, like I said, you're going to have to decide, how you're networking those devices together as a controls contractor, whether it's a straight daisy chain or a loop. But for all intents and purposes here, you're going to say you've got a maximum of 50 on a daisy chain because you've looked at your specified products, you've seen their product data, and their product data says a maximum of 50 VAV boxes on a daisy chain. So if you've got 60, then you may want to provide 2 JACEs, right? And then connect something else on that MSTP loop, on that BACnet segment, right? So now you've got 2 JACEs, 3 JACEs, and 1 fire alarm panel. So that's 4 ports on our 8-port device, right? So we've got an 8-port switch. We've used up 4 of those ports. Now you've got your lighting controller that goes out to all the lighting devices on the first floor, right? All the lighting controllers on the first floor. That's an IP device. Remember, if we go back to our schedule, the lighting controller was an IP device. So now we're connecting directly to the switch. So now we've used up 5 of our 8 ports. And then our HMV unit, we said that also was an IP controller. So for this particular example, we've got our first floor equipment pretty much diagrammed out to our first floor switch, right? So as a consulting engineer, if you show this on your drawing, that's plenty for a systems integrator to look at and say, I understand his intent. And remember, as a design professional, you always want to express intent. This is enough information that I'm sure that any systems integrator on the line right now would agree that this is enough information for them to understand what the intent is, right? So now we've got our design intent, and we know that we've got all this technology that's on the first floor, right? So we've got a fire alarm, emergency generators, an HMV unit, and a bunch of VAV boxes and a lighting controller on the first floor. So let's take a look at the overall topology. Okay, so now we've taken a look at the front end or our integration platform, right? So we know all of the hardware and software is going to be in our front end for our network, right? So now we've got it all in a cabinet. We figured out what our first floor looks like when we look at a schedule. Now we're looking at the first floor. So we've got one of our segments designed and laid out. And this is what we're looking at as far as an overall topology for our 5-story building. So as a consulting engineer, this is the type of drawing that we have to get used to developing and learn how to develop for our systems integrators, right? Because the controls industry is entirely different now. It's a lot more sophisticated. You know, we're in a data-driven world now. So now we're at an age where we've got IP devices, we've got IT professionals involved in the control side of the business, and we, as designers, have to be capable of designing self-contained IP networks, and we as systems integrators have to be capable of standing up and managing these IP networks. So we have to merge as an industry and help each other out. In other words, designers, let's get adept at designing these systems. I suggest to most consulting engineers that I talk to just implement another drawing into your drawing package called a systems integration drawing. In other words, an SI drawing. And what's going to be on that SI drawing? You know, a detailed topology like this, right? This is a detailed topology. When you look at every floor, you know, the type of controller, the type of media, the quantity of the controller, what that controller is actually controlling from an equipment standpoint, so that you can go and look at your equipment schedules and match them and coordinate the equipment schedule to your controls drawing. So the typical controls drawing that just shows an air handler with all the IOs, you know, that's fine. You still want to implement that into your drawing package, into your construction documents, but you also need to start implementing a systems integration drawing. Right? So this systems integration drawing, of course, you can see in the top right-hand corner, there's all your general notes. Those are the things that you tell the systems integrator to look at, right? You know, this is diagrammatical in nature, blah, 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 right? All your CYA notes. But as a systems integrator, you look at a drawing out of an engineer's office that looks like this. You should be able to roll this drawing out and look at it and say, okay, I understand what the intent is, right? I know quantities of controllers. I know that the guy wants a combination of BACnet MSTP and BACnet IP. I see what systems or technologies are actually being integrated into the overall system. I see that they want a separate OT network. I see that that network solution is using actual fiber, right, to connect all the edge switches together. I see how many ports each edge switch has at each floor, right? I'm showing gateway devices. I see that they want redundant front-end network managers, right? I see that they have an on-site server. I see that they want wireless access. And I see that they're using Niagara. And in the top left-hand corner, you're going to want it all in a server rack. You can say wall-mounted server rack in the facility engineer's office, room 101-3, right? You can put as much information on this drawing as possible, but remember, as a design engineer, we're only trying to show intent. So you could put an integration matrix, right, that shows all of the stakeholders who are involved in the integration process, right? So it's mainly going to be the electrical contractor, right, for fire alarm and emergency generators and lighting controls. And it's going to be the HVAC contractor. So you're going to have those three contractors involved in your systems integrator, right? So those are the four entities that are building stakeholders that are going to be involved in the integration process. So if a commissioning agent is on the job, they can actually, know what the intent is and help to push the process along when it comes to being a third party entity for the owner. So this helps out everybody that's involved in the project when talking about standing up your own separate IP network. So hopefully this gave you enough information to understand, what's required. Know that, Cochrane Supply Engineering, we've developed a couple specifications, both a Division 23 and a Division 25 guide spec for the consulting engineers and the end users. And, we've been doing this for quite some time. We're one of the largest agro suppliers in the world. And we know pretty much every systems integrator and master systems integrator out there. So if you guys are looking for help recommending people, we do that. And we can assist with any project, no matter how large or small, when it comes to standing up your own IP network. So if you need assistance with technical drawings or laying out topologies or anything like that, just give us a shout and let us know. If you got any questions regarding the content today, hopefully it was helpful. Again, my name is Greg Fitzpatrick, and my email address is gfitzpatrick@cochranesupply.com. And my phone number is 248-217-4484. Like I said, I work in business development in the area of IoT and integration. I do a ton of drawings and support for the consulting engineering community. Also help out quite a few systems integrators when it comes to laying out some of these systems. So, rattle our chain, give us an opportunity to help you guys out. Hopefully this was helpful. And thanks for joining us today. And hopefully we'll see you for the second part of our Smart Building Design series. Thank you and have a great day.